Okay, everybody, this is algebra class. This is lesson 39, using the distributed property to simplify rational expressions. I can tell you from personal experience that students actually will find it easier to do this lesson than the previous lesson, which was like, factoring out. So this is sort of the opposite of the previous lesson. Okay, this is going to. Okay, so let's get started. This is lesson 39, using the distributive properties to simplify rational expressions. Go to the new concept on page 243. Okay, and let's read this. It says a rational expression is an expression with a variable in the denominator. Rational expressions can be treated just like fractions. As with fractions, the denominator cannot equal 0. Therefore, any value of the variable that makes the denominator equal to 0 is not allowed, not permitted. Variables stand for unknown real numbers, so all the properties that apply to real numbers can apply to rational expressions. The distributive property can be used to simplify rational expressions. Okay, so let's take a look at the first one, and maybe we'll see something that will show what they're talking about here. Okay, so simplify x squared over y squared times this. All right, and I think it's going to be easier if you see me do it rather than talk through what they have. Okay, so let's do this. Okay, so we have outside the parentheses, we have, we have x squared, let's make that good, over y squared, and then in parentheses we have x squared y plus 3y cubed times m. Okay, so you're going to distribute this x squared y squared to both of those insides. You're going to multiply. Alright, so let's do the first. And just like a fraction, you're going to multiply top to top to bottom to bottom. Top to top, bottom to bottom. So first you do x squared times x squared. Well, we know if you have the same variable, you're going to add exponents. So that's why that would be x to the fourth. Okay. Y squared times y would be y to the third. Okay, plus, and then distribute the x squared, so 3x squared times 3 y to the cubed would just be 3x squared y cubed. Now notice I put the 3 first because it's nothing changed. You just added the y squared to this, but because you have the coefficient goes in front. Okay, that's why. So the x squared became part of this, but you want to put in alphabetical order. That's why the x's came before the y's, and the coefficient goes out in front. And then y squared times m, you would put the m and then the y squared. Okay, so let's see how they did. There you go. And you can see they have, let's compare the answers here. X to the fourth over the y to the cubed plus 3x squared y cubed. Okay, yeah, they did one more thing over my squared. Okay, so they did one more thing. Because you see you have 3 y's here and we have 2 y's, you can, and we'll need to reduce that. So everything else stays the same. Okay, 3x squared. And remember what you would do is you would subtract exponents. So that's why that would be y to the 1. Okay, so that's a 3 minus 2, leaving you with just y, okay, or y to the 1. We don't need to put a 1 there, okay, and that's the simplified answer. All right, select all, edit, cut. Okay, it's just the first example. So some of you might be saying I don't understand that. Okay, well, we can, it's just the first example. Let's go to the second one. All right, second example. We have m over z. Need the pen. We have m over z, okay, times axp, all these are just variables, over mk minus 2m to the fourth p to the fourth. Okay, now let's distribute. Alright, so we're going to multiply m times this. Well, that just goes in the middle of it. A, M, X, P. Actually, that isn't an alphabet. alphabetical order is it, because the x would become at the end, but we'll put it like that. Then z times mk would just be mkz. Okay, now look to see if you have any of the common ones to reduce it. You do. You have you have an m here and an m here. We're going to cancel those each other out. Okay. All right. So let's just remember. We'll do that now. We'll just remember to put that correctly. Okay. Now with this one, 2m to the fourth p to the fourth, you got to remember that it's like a big whole number, and it really, even if it's not written, it has a 1 underneath it. So we're going to multiply m times that. So it would be 2m to the fifth p to the fourth. Okay, notice the only thing that changed was the m, because we have an m there, so that m times m to the fourth, we we add the exponents. That'd be 1 plus 4, that's what we have 5. Z times 1 is z. Okay, and that's as far as we can go. So that means that our answer for this one is, all right, so I'm going to rewrite it nice and neat. AXP over KZ minus 2m to the fifth p to the fourth over z. And I don't have anything else in common, so I'm not going to be able to do anything else. Let's see if I have the right answer. AXP over KZ, ZK, same thing, minus 2m to the fifth p to the fourth over z. And there you go. And that's the answer. Okay? All right. Simplifying negative exponents. Okay, and we know, remember from last time, what negative exponents means. Negative exponents means that basically it just wants to, if it's at the top, it wants to go to the bottom. If it's at the bottom and it's negative, it wants to go to the top. Okay? So let's go ahead and see what this one looks like. Let's move it to the top here. There we go. Okay. So we have B, come on now. B to the third, D to the negative third, okay? And this will be 2b squared D minus F to the negative 3 D all over B. Okay. My recommendation is to move those negatives first. You know, never move the negative exponent. So this is D to the negative 3. Well, that means that it really is D to the third. Just move it before you multiply it. And then rewrite everything. Okay, and then again this one minus, that's F to the negative 3. That means that it just wants it to be down here, F to the 3, and it becomes positive. Once you move it, it becomes positive. Now you can go ahead and multiply, distribute. So B to the third times D third, remember that's over 1, okay, because that's like it's at the top, you know, and just move the D to the negative 3 up here, and then 1's underneath. So we'd multiply that. Okay, so B to the third times B to the second, right? So that's 2B to the fifth, and the D to the third comes for the ride, over 1 times D is D, okay, minus B to the third times D to the third, so, B to the third, D to the third times D, so that's B to the third, D to the fourth, over 1 times 1 B, and that's to the third. Okay, now you need to simplify. Okay, so we have, let's see if I can, okay, so we have, that's D to the third over D, so you would subtract those, so that's B, 2B to the fifth, D second, minus, okay, B to the third and B, you would subtract that again. So that's B to the second, D to the fourth, over F to the third. Okay? And let's see if I got that right. 2b to the 5th. There's our answer, 2p to the 5th. Oh, let me see. I don't know. So you can see it. I'm trying to do it so you can see it here. Okay, there we go. 2 to the 5th, d to the 2nd, right? That's what I have. Minus b to the 2nd, d to the 4th, right? Over f to the 3rd, and there you go. Okay? Alright, these get complicated, but the thing is, if you take your time and you really look for the things they have alike, you know, that's what you're going to end up doing. You're going to, you know, you're multiplying, you're adding exponents with the same variables. If it's the same variable, you might end up, if it's division, you subtract it. Again, I recommend that when you have these initially, what you do is you want to move the negatives first. Okay. Okay, so I will, I'll do this one here. You can see the answer, but I'll do it here. I just want you to be able to see it. Okay, all right, so we have n to negative 1 over m times mx cn negative 3 p negative 5 plus 5 negative 4 p negative 5. And notice they are not changing the moving the negatives first. I don't know. I think it's easier just to go ahead and move them first and then go ahead and multiply it. So I'm going to move mine. I'm going to move the n down below because that's where it wants to go. If it's a negative exponent, it wants to switch positions. And then like the n wants to go up top. So I have m, x, n to the 3rd, and the p wants to go up here, p to the 5th. And what's left down there? Down there, and this is c. Okay, plus. All right, and we have the 5 up top, but the n to the negative 4, and the p goes underneath. So n to the 4th, p to the 5th goes underneath. Okay, now I'm going to multiply it. All right, I'm going to distribute this and this. Okay, so 1 times that. All right, so that doesn't change anything. That would still stay as m x n to the 3rd p to the 5th over, now multiply that would be n m c. Okay, 1 times 5 is 1. 1 times 5 is 5, and then n to the 5th m p to the 5th. Okay, I'm going to stop there because I'm almost out of time and I'm not done with the problem. So I'll start at this step for the next video. This will be the very first video of this lesson, and I will write this clear and we'll start there. Okay.